All right. Thank you, everyone, for joining the Corundum developer meeting today. Today I just have some status updates. So I'll go ahead and work through these. So one thing that I just did a couple days ago is I went ahead and pushed all of the current, basically my current development branch up to the core code base. After going through and testing all of the target designs on all the boards, just to make sure that I hadn't broken anything. And I've been trying to do this for, I don't know, at least a couple of weeks now because I've been trying to get these scripts put together so I can, do this testing. And in the process, I discovered several bugs that had to be fixed. So I'll talk about that a little bit in the next couple of slides here. Um, yeah. And then the things that I'm going to be working on next are like the MSIX interrupt support, the segmented interface for the PCI Express TLPs, the variable length descriptor support, and the clock info block are those kind of the main things that I'm going to be working on next. And then at some point, I also have to get the software working and finalize the 10 gig, 25 gig switching and get that running on the software. So yeah, that's the summary of everything. All right. So in terms of stuff that I've kind of fixed in relation to getting the code pushed up to the repo, um, for a while the mux modules used in a few places have had some issues. So what I did is I added input pipeline registers to all the multiplexers, which will pipeline the arbitration delay. So this does two main things. First one is it ensures that you get 100% throughput in all cases. Previously, if you just had one input active, then you would suffer a 1 cycle delay between packets, such that the round robin would work correctly. And then priority arbitration didn't quite work right due to the adjustments I had to make to get round robin working properly. Priority would basically round robin between the two highest active priority levels, which is not how it's supposed to work. So, with the input pipeline registers set up, now we can get 100% throughput in all cases with no, inserted stall cycles, and the priority arbitration works correctly even if you just have, two active inputs. Um, and this means that now, like the control DMA operations and the bulk data DMA operations are now correctly prioritized when they're handed off to the DMA engine, which will hopefully improve the performance a little bit to make sure that the descriptors are read before the data, just to make sure that we can continue generating those read requests for the data, or the read and write requests, I suppose. Yeah. Let's see. And then in the process of testing everything, I discovered a number of bugs. Some of them I introduced or uncovered. Um, and let's see. So the first one is there was a race condition in MQNX stop port that occasionally, with pretty high probability, caused the system to crash with a null pointer dereference. So yeah, I fixed that. Just had to make sure to basically stop the nappy polling before doing the other teardown stuff. So yeah, that's now fixed, and that makes things a little bit more reliable. I fixed the RX PTP timestamp handling in the CMAX. I can't remember when I introduced this particular issue, but basically the CMAC it only outputs the timestamps on the first cycle of the packet in its timestamp output port. Um, so I just directly wired that to the T user sideband signal. But in the current setup, I'm looking at the last cycle of the packet to extract the timestamp out of the T user sideband signal. So it was getting zeros instead of the timestamp. So I had to add a little bit of code to handle that. So yeah, now PTP works again on all of the 100 gig designs. And then as a related problem, I discovered a somewhat similar issue in the 10 gig and 25 gig Mac module, where under certain circumstances, it was reporting the timestamp for the wrong packet in the last cycle of the packet on the T user sideband signal. So I fixed that, which should make PTP timestamping more reliable for 10 gig and 25 gig. I also, as part of this, added a bunch of test bench code to the Verilog Ethernet repository to test all the timestamping for all the Macs. So that all now works. And in doing so, I discovered a couple of bugs in the PTP CDC module. So I fixed those. There's an issue with the integrator saturation and then how I was handling some active clock edge detection stuff. That's now fixed. Another thing I did, this is more of an improvement than a bug fixed, is I added RX status outputs to the 10 gig, 25 gig PHY module. And this is more reliable than the RX block because it's generated by the watchdog code that I added a while ago. So it's looking at block, but it's also looking at a couple of other signals in terms of bad blocks and framing errors and a couple of other things. And it's got to make sure that it doesn't see any of those errors in a certain amount of time before it'll report the link is actually being working. So this one is now being used for all of the RX status connections and also for the link lights on the back of the NIC. So previously, I think like for whatever reason, some of the ultra scale devices seem to be more affected than the ultra scale plus devices, but I had a big problem with flickering link lights, even with no cable plugged in. So using RX status, not a problem anymore. If there's no cable plugged in, that light is off, which is a good sign. Yeah, so this should be good for the MLE guys that are trying to get link status reporting working in the driver. We now have a better source of ground truth for that. I also discovered that on the Alveo U200 and U250 designs for 100 gig, I was missing a bunch of connections at the top level. Well, not the top level, like one level down. I just forgot to put them in for whatever reason. And yeah, as a result, the I2C communication to the optical modules wasn't working. So I discovered that in running my test scripts. I'm like, well, it works at 25 gig. Why doesn't it work at 100 gig? That's weird. After some head scratching, I eventually found those missing connections, put them in, and well, now things are working at 100 gig completely. So that's good. I also added another parameter to the config.tcl files, at least for the 25 gig designs, to disable the TDMA BER modules because those are, for the most part, not necessary. We use those in our test setup with the optical switch and whatnot. So turning that off saves a few logic resources, especially because those run in the same clock domain or partially run in the same clock domain as the Ethernet PHYs. So at on the 25 gig designs, that can kind of cause stuff to get a little bit crowded near the PHY modules and can cause some timing closure issues. I think I was having some issues associated with that on the Bitware XGP-P3R board, just with that has more ports than most of the boards, so that just created some crowding issues over there. So turning that off makes the placement a little bit better. And then finally, I fixed the MAC address Eeprom offsets on the Xilinx dev boards. Some of them come with blank Eeproms, but it seems like most of them don't. And the ones that don't have possibly a MAC address programmed at an offset of 32 into the Eeprom instead of offset of 0. So I changed everything to offset of 32. On a couple of the boards, I think it was programmed on a couple of the boards. Boards had a MAC address sticker on there, but at address 32 in the EEPROM, it was 1, 2, 3, 4, 5, 6. So definitely a placeholder MAC address. The annoying thing, or maybe it's not annoying, I don't know, is that 1 sets the broadcast bit, so it's actually an invalid MAC address. So if it's there, Corundum won't use it, which I guess is a good thing. So you'll just have to go program in the MAC address from the sticker on the board, which is not particularly hard to do if with XXD and DD to make that happen. So I think this applies to the VC118, VC108, CC106, and the VC1525. Yeah, I think out of all those boards, one of them was programmed correctly, one of them had a blank EEPROM, and 2 of them had the placeholder MAC. So you definitely can't rely on the correct MAC being there. But if it is there, then the driver will read it out properly. Yeah, and I think it might have been for well, so previously when reading from address 0, it was reading something else. but it's like text, so it will actually use that as a Mac, but it'll be kind of a garbage Mac. So anyway, that makes things a little bit more useful. All right. And then I have the hardware test scripts that I went ahead and committed to the repository. They probably still need a little bit of work, but first pass, they seem to be doing what they're supposed to do. So these scripts are kind of a rehashed version of the scripts that I put together when we collected the FCCM results. So there's basically three different scripts. The first one is a very, very simple wrapper for iPerf that helps you start up multiple instances of iPerf and then shut them down when the script exits. It also manages NUMA and network namespaces. So if you give it like the network device name, then it'll make sure that iPerf is always bound to the correct NUMA node. And if you give it an IP address as well, it will create a network namespace, put the adapter in that namespace, bind it to the correct NUMA node, and configure the IP address on there so that you don't need to do any other screwing around with configuration tools. You can just run the iPerf wrapper. It'll set up the interface and start up iPerf, and then it's also capable of starting up a PTP Grandmaster instance, which is then used by the main test script. So the reason I put this together is I came to a realization that it's actually you don't need to do all that much in order to set up this system for bandwidth testing and whatnot. So the previous set of scripts that I had actually used SSH to connect from, effectively I had them running on my desktop machine and then used SSH to connect to two different servers, one as the source and one as the target basically. And then it would run iPerf on both of those and then report back the results. But SSHing and running stuff as root is it's not very clean. So eventually what I realized is that there's actually no reason to do that. If I just run a bunch of iPerf server instances, asynchronously, separately, then you can just poke at those from, one script running on one host, on the same host as, one of the NICs. And then you can do all of the network namespaces and other configuration and whatnot. So the idea here is that you run the test script on the host that has the Corundum NIC, and then on the link partner on some other NIC in the network, you'll run PIPerf to set up a bunch of iPerf servers that will form the other end of the connection. Right. So that's PIPerf. iPerf bench is kind of the next level up, and this one sweeps a number of iPerf processes and records the bandwidth. So it'll run with one and then with two, so on and so forth. It writes out CSV files that contain information extracted from iPerf as well as some other information collected from the system. So it records like the transmit and receive packet and drop counters and whatnot. So from that, you can get kind of a rough idea of how things are working. And finally, we have the test MQNIC script, which is kind of the high-level NIC test script. So this runs the bandwidth test using iPerf bench and PIPerf, and then it also runs tests to check the MAC address to make sure it's getting a valid MAC address, the module I2C communication to make sure that works. It also runs the PTP as well to make sure that PTP time sync is working and it's sufficiently accurate and whatnot. So yeah, the idea is that you can just run this one script and it'll give you a reasonable idea of whether the hardware is doing what it's supposed to do. Right. So I've run this on basically all of the targets. And another thing I suppose I discovered after much head banging is that it seems like the Mellanox NIC transmit timestamp path doesn't work very well. So it's fine under light load, but under load, the transmit timestamps are garbage and the sync is all over the place. So not sure exactly what's up with that. I thought the Mellanox NICs were better than that. That's with the ConnectX 5. I know the ConnectX 4 had some issues, but apparently the ConnectX 5 also had some issues. Anyway, so yeah, those are the test scripts. Those are now in the repository, so we can use those as another verification point when testing things out. Let's see. Moving on to stuff that I'm going to be working on soon. So what I'm working on right now is getting MSIX operational. I got to put together a module that implements the the table with all of the vector addresses and such, and also the pending bit array, the PBA. So that's what I'm working on now. And this, again, there were kind of two main reasons behind doing this. One of them is that MSIX will allow you to support a lot more interrupt vectors. Um, and and as kind of an addendum to that, some systems, for whatever reason, only enable one interrupt vector in MSI, even if you request 32. Don't know why. If somebody knows why, it'd be nice to know. But some systems enable all 32. Some systems only enable one. This nice new workstation machine that I got for testing some of this stuff, it only enables one. So if I get MSIX working, then things would work on here. And the other thing is MSIX is required for SRILV. I'm assuming this has something to do with like the IOMMU and whatnot, and being able to plug in different addresses for the different vectors, but I'm not 100% sure the reasoning for that. Anyway, progress being made on this front. I'm getting that module putting together and starting to get things integrated. I got to make some modifications to some of the simulation framework components, because I think right now the simulation framework only supports MSI. So I got to add a little bit of additional stuff to make that work for MSIX. Right. So that about rounds out MSIX. And then the other thing that I'm going to be working on is getting the segmented PCI Express interface working. So this is supporting transfers of either multiple TLPs in the same clock cycle or parts of multiple TLPs in the same clock cycle. And the idea here is to improve the performance of the interface to the PCI Express IP core. Right now, Xilinx devices actually cannot hit 100 gig line rate, even or with TLP straddling disabled. So that's just one TLP per clock cycle. It gets pretty close. I think it gets to like 97, 98 gigabits per second, something like that. But line rate is at 100 gig is, or with 9K MTU is higher than that. So that's an issue. And the solution for that is, and to actually get to 100 gig line rate, you need to do this. You need to get the segmented thing working. Intel devices, or but at least Xilinx devices allow you to turn the segmented interfacing off, so you can have a somewhat simplified interface to the IP core. So that's what I've been doing because it's a little bit easier. Intel devices, on the other hand, they also use segmentation, but you can't turn it off if it's required. So for Gen 3 by 16, Gen 4 by 16, it's in two segments, and you got to deal with it. So in order to get things running on the Intel dev boards at Gen 3 by 16, we need to have this operational. So yeah, I'm going to take a look at that and see if I can get it working. The other reason for this is that I was trying to get right now all of the Xilinx designs use 64 PCIe tags, and the reason for that is that the UltraScale devices only support 64 tags, and I got everything working on UltraScale, and then when I moved to UltraScale Plus, I just left that alone. At some point, I tried to change it to 256 tags, and it just crashed and burned, and I couldn't figure out why. The Intel design uses 256 tags, so not exactly sure what's going on there. So I think last week I did some poking around to try and kind of isolate what exactly was going on here. Now that I have the PCI Express DMA code, I have a more repeatable way of testing the interface and stressing it, seeing where things break. So I dropped an ILA on there and discovered that under certain circumstances, the Xilinx PCIe IP core is giving you garbage TLPs on the RC interface. So this is coming from the host back into the FPGA. And garbage because the fields in the header are complete nonsense. It looks like it's getting, some random bit of data from one of the other packets in the header instead. So yeah, not exactly sure what's causing that, but my assumption at the moment is that this is related to the soft logic that converts between 256 bits and 512 bits. because on the UltraScale Plus devices, the PCI Express IP core internally is 256 bits. They just run it at 500 megahertz and then have a width conversion to 512 bits. But I think when you turn off the straddling support, then they have to de-stripe that interface internally. And I suspect that there's a bug in that code somewhere. And I think it has a FIFO in it. So once that FIFO overflows, then things break. So if I can get this segment interface working, then I think it'll work around that bug, and then we'll be able to get all the tags active and whatnot and get better performance. So this is to do once I get MSIX working. And then after that, I'm going to hammer on variable length descriptor support, see if I can get that working, because I did a little bit of benchmarking on one of these slightly slower AMD EPYC machines that I have here. And I was seeing some weird behavior where the if you're running both transmit and receive traffic at the same time, you basically get a convergence between the throughput of the transmit and receive traffic at a particular level. At like, I don't know, it was lower than I was expecting. Like both the TX and the RX were like converging at like 18 gigabits a second or something like that, which is much lower than it should be on the Intel devices. So I think this is related to something to do with CPUs here. Potentially, if we get these things running with more than 64 tags, you'd get higher throughput. But because we have this strange kind of bottleneck going on, so that the weird thing is not so much that it plateaus, but it's like the TX is going down and the RX is going up, and they kind of collapse at one point. It almost seems like there's some sort of a shared resource that's limiting both the transmit and the receive to a particular level of performance. And I suspect that that's related to the descriptor fetch, because that's really the only thing that's shared between TX and RX. So if we implement variable length descriptors, then we can perform these fetches in a much more efficient way, and that should hopefully improve the performance. So that's something to work on over the next couple of weeks after I get MSIX and the segmented PCIe interface operational, and hopefully that'll help improve the performance significantly. Also, now that I have these test scripts, that should make it a lot easier for testing in hardware, and hopefully I can test on this guy, which will have similar performance to the servers that we have in the CSE building. All right. And then there's a couple other features that it's been on the to-do list for a while. Management software. I'll work on this after we have these other couple of things squared away and get that operational. 10 gig, 25 gig switching. Once we have the software, then this will run on the software. And then the clock info register block. At some point, I'll hammer this out. Potentially, if I get frustrated working on something, I'll take a break and hammer this out. We'll see. But that'll get squared away relatively soon, I think. I'm not sure if there's any other major features that I am forgetting at the moment, but that about sums it up, I think. Does anybody have any questions, comments, concerns, etc.? Or are we just going to turn it over to the folks at MLE, like we usually do? Nobody? All right.
No.
Oh, what's up?
Oh, this is Bob. Can you hear me?
Yeah, I can hear you.
Yeah, real quick, the X100, they're the K3 PQ, the card there. You said that that particular device only has 100 gig CMAC, I think. That's what you said.
It has 0.
0. I thought you said it had 1. Okay. All right.
It has none. I was actually thinking about putting together a 100 gig design for it. And as part of that, you got to go in and generate the, or at least figure out where the CMACs are, so you can, assign one per port. So I went into the to Vivado in the IP catalog, and I'm like, where's the 100 gig Ethernet subsystem? What's going on here? And then I went and looked at the data sheet, and it's like the smallest one has a 0 Cmax. I'm like, oh, okay. You got to go up to like an 11p or something like that before you get it 2 Cmax. So, yeah,
Well, we only need two, but yeah, we don't have any. Okay.
yeah, it's weird. Like the lowest several Vertex ultra scale parts have no Cmax at all. You got to go, or the lowest couple of Kintex ultra scale parts have no Cmax at all. Let me take a quick look at the product table. Where is that file? Let's see. I got ultra scale plus, I think, the product selection guide. Yes. Okay. Yeah, let's see. Okay, so KU3P, it has 0 Cmax. The KU5P has 1. 9P has 0. The 11P has 2. The 13P has 0. 15P has 4. The 19P has 1. It's all over the place. What's up with that? But yeah, so KU3P has no Cmax. So if you want to do 100 gig Ethernet, it's going to have to go through. You're gonna have to do a soft MAC basically.
Right. Right. Well, yeah, we want to do that, but I'll have to see where I can find one, a soft Mac. Maybe we can get one from our team or.
Yeah, maybe. Well, I mean, for your guys' low latency stuff, you probably want to do something custom anyway.
Oh, yeah.
But,
yeah. That's
but
what we do. Yeah.
right.
Regularly,
Yeah.
But we don't have 100 gig right now that works on that.
You don't
on
have
that
100
card.
gig at all, or that works on this
No,
card?
no 100 gig whatsoever.
Okay. Right.
So
That's what I thought. Yeah, I was actually looking just briefly at what it would take to build a 100 gig Mac, and those things are frapping complicated.
I bet, yeah. So we may, I don't know, I got to go back and ask our team if they know of anything, or they have something, or they're working on something, right? Or a
Right.
product.
Yeah. So just yeah. So in terms of 100 gig max, the thing that makes it complicated, well, so there's really two main things. One of them is you got all of these virtual lanes, right? So 100 gig max, they use 20 virtual lanes internally, such that you can bitmux between what you can do 4 lanes, you can do 10 lanes, you can do 2 lanes, you can do 1 lane. The idea is you can do a whole bunch of different, you can convert between a bunch of different lane widths just by doing bit level multiplexing and demultiplexing. So to support that, they have these 20 different virtual lanes that it runs across, and you got to figure out, which virtual lane is which when you peel everything apart at the receiver. So, yeah, that makes things a little bit more complicated. But to be honest, the deal breaker is the fact that well, maybe not most, but a good number of 100 gig devices require RSFEC to be running. Like, I have not been able to get the Mellanox NICs to work with RSFEC disabled at 100 gig. So, not sure what's up with that. Maybe there's a way to do it. But, if you don't also implement RSFEC, then you might not be able to bring up a link with, certain devices.
Okay. All right. Good to know.
So yeah, if you're trying to do low latency stuff, that might be a problem.
Yeah. Oh, yeah. RSFEC will be a problem. Well, we know that already. We do have a 25, a 25 Mac. It's low latency, but when FEC's turned on, it's not. Right?
Yeah, that's kind of an equalizer there, isn't it?
Yeah.
Yeah, actually, so the 25 gig Mac that I have, that I put together, is basically the same as a 10 gig Mac, and it doesn't implement any kind of FEC. And for the most part, it seems to work. So it seems like most devices that implement, or at least all the devices I've come across so far that implement 25 gig, they don't require running the FEC at 25 gig. But for whatever reason, certain devices seem to be requiring it at 100 gig. So yeah, just FYI.
Okay. No,
that
that's good
was
to
the nice
know.
thing about the Xilinx CMAC, is that it has effect built in, and you don't need a separate license for it or anything. You just turn it on and it works. So yeah.
All right. Okay. Thank you. That's all I have.
Sure. Yeah, then I guess we also had that discussion about serial numbers, and got me thinking about if there's any way of exposing, or any kind of standard way of exposing information like that, in Linux. So I don't know if if there's some standard interface or API that wasn't able to find for that sort of thing. I know there are some PCIe fields, some, I guess it's what was it, the DSA. There's like a device serial number field, and then also a product data field that can be exposed in the configuration space. So those are potentially two options, kind of at the PCIe level, but I wasn't able to find anything like at the network device level, which I guess maybe makes sense because you get MAC address, and that's effectively a serial number, or should be a serial number anyway. I don't know. This is more of a driver development question. If we have anybody on here or listening it on YouTube afterwards that is more familiar with that, would be cool to hear if there's any standard ways of doing that. I mean, I think Bob, you're saying like the FDK has some registers where you can read that information out of, but that could be, I think that's probably an FDK specific thing, right?
Yes.
Yes, yeah. So,
and well, for our NICs, it's specific to our utilities, right? To read things like that out.
Right. Yeah.
And then
yeah.
other NICs, like you said, LSPCI, and they put it in the vital product data. Some of them do, some of them don't. Some of them use that other field. Yeah.
Yeah. So it doesn't seem like there's a very standard way of doing that. So
no. Yeah, it's even within a given vendor. I don't, because it evolves, right, kind of thing. So yeah, there's no standard way I know yet.
Right. Yeah. So the one thing that I did find that seemed promising is there's a ETH tool, an ETH tool API for getting some information about the hardware, but this is more about like version numbers, and like the PCIe device ID, the bus device function number, that sort of thing. But it doesn't have any fields for serial number or product number or anything like that. So yeah, not sure. I mean, it wouldn't be too hard to expose something like that with a sysfs entry that applications could read. And again, it also wouldn't be too hard to add some fields to the data structures that would be accessible from like the extension device drivers and whatnot. But yeah. And I guess once we have like softcore working, then we could probably have a high level API for the softcore to request, hey, what's the serial number for this card, or what's the part number for this card. But yeah, then the question is, what do you do with that information? So that's something potentially to be discussed if anybody has any ideas about that. Maybe not right now,
right?
But just to get that idea out there. All right. Okay, so does anybody else have any questions, comments, concerns? Or are we going to turn it over to MLE at this point? I see Ulrich is back. We lost you for a minute there, Ulrich.
Yeah, I got a call. Sorry.
Okay.
I'm back now.
All right. Well, how are things at MLE in terms of Corundum? I know you guys have been doing some timing closure work on the Stratix 10 devices. How is that progressing?
Yeah, I think my colleague should reach out to you with respect to the Axili tree. There is some, I guess the signal is FIFO select, which pops up every time now.
Okay.
So we have to look into this. And even we added some register slices into this, these branches, and this just does not go away. So maybe there is something in there that bypasses the actual data path and needs additional pipelining. Let's see. But I guess so Simon, who's working on this, told me today that he will contact you, and I don't know if he already did, but
I don't think I've seen any mails recently, but I'll be keeping my eyes peeled. Maybe it'll take a day or two before he'll get that email out. So
he probably does it early tomorrow, and for him early tomorrow is my night. So
yeah, that's fine.
it's your evening, possibly.
Right.
Yeah,
Okay.
and on the other side, I don't know if Joachim already said something about it. So he opened the pull request, providing the driver side of the link status report.
Oh, okay.
Um,
I didn't
with
see any
East
email about
tool
that. All right, I'll take a
support.
look.
Yeah, I guess maybe Friday, today, I don't know, recent.
Okay, I am taking a look at it right now. My email's been funky recently. Anyway, all right, there we go. Yep, I see it. I'll take a look at that, and we'll take a look. Yeah, that should be useful. That looks like it should be a pretty simple thing to merge in then, if it's just a couple of changes in the driver. So yeah.
I mean, there's potentially one point to discuss, which depends on what a specific design looks like. I would say that's the point in where one interface has multiple ports. I mean, that's not the case in any of the in any of the default designs, I guess. But if there would be a design, then what's the status of the netdev? And the current solution is I applied is, well, all have to be up to say up. I guess that's the most the thing which makes sense without knowing anything else.
Right. Okay. That seems like a pretty straightforward solution. Yeah.
Yeah, and your changes to the instead of using the RX block log signal also made a difference for us here on the ZCU, of course, and also on the Sidewinder board we have here. The status is really pretty stable. If the remote side is powered down, no power applied, then the link stays down and doesn't toggle like with block log.
Right. I mean, it sounds like you're qualifying that under certain circumstances. Is it unstable or?
No, that no written down conditions. I just said,
all right. So I guess you've had a problem with that before. That the host was off and it said the link was up, and you're like, what?
Right. Yeah.
And now you're not seeing that now. Okay, got it.
The link turned up multiple times per minute, so that was easy to spot and reproduce. Just let it sit there for 2 minutes and see. Well,
right.
8 times that's, link up, link down.
Yeah, that's not as bad as the as on the Exadec X10, where when I had both cables unplugged, the 2 link lights were sitting there flickering. I'm like,
Okay, no, that's
that was like hundreds of times per second or something. So yeah, just something about the Kintex, or something about, I think the UltraScale series transceivers just seem to be triggering the block lock much more often, even with no cable plugged in. UltraScale Plus seems to be better, but apparently not perfect. So well, it's good to hear that that's working better. So cool.
Yeah. And the other update is regarding page pool API experiments.
Okay.
I don't know. I guess Gira is not here today. That's unfortunate. I tried to reach out to him, but I guess perhaps he's missing some Slack comments.
Yeah, I sent him a couple messages on Slack too a while ago and didn't hear anything back. So I don't know if maybe he's just not getting any sort of notifications from that. But whatever.
If I remember correctly, he said in one of the last meetings that he fixed issues with his page pool API solution. And but he posted his prior version in Slack, and based on that one, we took that in and made our own modifications, and can report the first results now, which is that it makes a difference, but the difference is not that big compared to I guess I talked about this before, compared to, for example, what Intel does in the IXGB driver, for example, where also interrupt coalescing is going on. But still makes a difference. The factor when looking at the time to the processing time needed for allocating an RX buffer goes down by roughly a factor of 3.5.
Well, that's pretty good.
Yeah, and I guess the special solution which the IXGB driver, I guess it's an older driver. They don't use the page pull RP yet. They have a special solution.
Several
but they
drivers
also
do weird things.
Yeah. But they also have their kind of smart interrupt or controlled regulated interrupt coalescing going on, which makes also a huge difference. But well, one step. The unfortunate thing is, however, that the page pull API, it's a thing which gets enhanced from version to version, and the enhancement, which is the feature which is needed, comes in at 5.14. Wasn't there before that point.
I see.
So
yeah, that's a good point. Yeah, for if you wanted to use something like page pool, especially on the older kernels like CentOS or something, or maybe not. Yeah, the older distributions. Well, I guess not so. On distributions like CentOS that ship old versions of the kernel, then you could potentially run into issues with that.
Yeah, definitely. Yes, unfortunately.
Yeah. Oh, and speaking of running stuff on CentOS, I did hunt down that that code that Alex Badeo was talking about, where we have the out of tree module for the auxiliary bus, and just to kind of get a sense of what that looks like. And they actually have kind of a nice little self-contained auxiliary bus module in that that code. So I guess that was the driver for one of the Intel NICs. I can't remember which one off the top of my head. I have the archive sitting around somewhere. But yeah, so it's a couple of files for the auxiliary bus code itself, like header file plus C file. And then there's a bunch of kcompat stuff, which I guess is the deal with the older, or trying to run newer stuff on older kernels, where you sometimes have to re-implement a few things or modify some APIs. So yeah, there's definitely a few pieces there that I think we'll be able to use. I haven't tried actually using that module myself. I don't know if I have I don't have a system set up right now with that kind of old kernel that we can play around with. But yeah, it looks like it shouldn't be all that hard to package that along with the main Corundum device driver, and then we can use that on systems which have older kernels that don't have the auxiliary bus support natively. So shouldn't be that big of a deal. But the more worrying thing is in that same code base, there's the kcompat stuff for the main driver, and there's like, I don't know, 5 or 6 different files. So yeah, I think we probably have quite a bit of work to do in terms of getting the Corundum device driver to run reliably on some of these other distributions. Although I'm not sure exactly which distributions these kcompat support is for in this particular Intel Intel driver. It looks like they're supporting several different distributions instead of like just CentOS, but we'll have to take a closer look at that. But I'm not sure how much we'll need to redo basically. If we're just doing CentOS, then it might not be that big of a deal.
Yeah, well, our I guess our CentOS patch is still pending. Only we have to talk about that if we also want to upstream that soon. At least our modifications, and these are pretty small modifications to make it at least work on CentOS 8.
Which modifications?
we have modifications to the MQNIC driver to at least make it work on the CentOS 8 kernel.
Okay. And this is, you have a pull request for this, or?
No, not
Oh,
yet.
okay,
And
okay, I see,
there's
yeah.
kind of a to do.
I see, okay. Well, that's
Yeah,
definitely something to take a look at.
Yeah,
I guess we don't
the
necessarily need
older
to go
things-
back a whole bunch of versions, but if you're just going back a version or two, it's probably not that big of a deal.
Yeah. Yeah, well, with page pool, it's an unfortunate and tricky thing because the kernel is updated in its core places, I would say, instruct page, instruct SKB. So there's no way to, add that with a module.
Right. Yeah, that's that one's much more deeply tied into the kernel. I mean, I guess the
But,
other thing with the page pool is I'm not sure how much benefit you would get just using the page pool by itself. From reading about, from the documentation I could find talking about the page pool, it seemed to be more geared towards supporting XDP than just general
definitely. Yes.
NIC devices. So
That was
yeah,
the
because
original
XDP
reason.
uses the pages. So the idea is that on the RX, you'll fill up a page, hand it off to XDP, it'll do some processing, and then it might give you the page right back and put that back in the pool so you can use it again without handing it back to the OS. I'm not sure if you're handing pages off to the OS for processing, if the page pool really helps you out there. I know some drivers have played some really weird tricks to effectively try to do that.
And that last point is a crucial thing which I added in 5.14, that you can mark an SKB with just a bit which says I have a page which belongs to a page pool and I want to be recycled. That's the key thing. Yeah,
because I've kind of been perplexed as to why all these other drivers have all these ad hoc solutions to that. It seems like the page pool would be a way to kind of centralize all that, and it seems like they've done that basically. So, or finally done that. The other thing
at
that
least
I've
it
noticed,
looks like this. Yes.
Right. Yeah. The other thing that I've noticed that some devices do as well is they'll use pages multiple times. So if you're using an MTU less than 2K, so like MTU 1500, you could put 2 packets in each page. And I can't remember which drivers do this, but I've definitely seen at least 1 or 2 different drivers doing that. Maybe it's an Intel driver. I don't know if the Mellanox driver does that. But yeah, so that one would also give you a performance improvement because you're using fewer pages. So
but in this case, they say, if I remember correctly, you're still on your own in terms of recycling.
You
are still on your own.
Yeah, probably, yeah.
If I remember correctly, so
yeah, so I don't know if that would work with the page pool, but I mean, I guess. Yeah, I'm not sure the best way to handle that from a maintenance perspective. I think if you were going to do something like page pool, you'd probably have to add, if defs. If you have a new enough kernel, then you use page pool. Otherwise, then you're just going to have to do it manually.
Yeah.
And
it's really a small change.
And maybe you just eat the performance hit on the old kernels. I mean, if you're not trying to run 100 gig, maybe you don't need it. I don't know.
So from all I can say for now, and it's really the first results, is it's kind of a 3-line changes, basically 3 types of lines. You replace the alloc, the free, and in the end, the third thing is you add the marking, where you say this shall be recycled. And the important point is it's really about only page recycling. I kind of mixed that up in the beginning and thought that has something to do with recycling SKBs even, but that's not the case. It was a wrong assumption on my part.
So the interesting thing about SKBs is, at least with the way things are currently set up, in terms of how the GRO code path works, the driver doesn't even really touch the SKB, right? It just kind of gets it from the stack and then attaches the data to it and then hands it
Yeah.
back to the stack. So I'm not sure if they're giving you new SKBs or if they have a small pool of SKBs
Well,
or what.
they
but it
have,
works.
yeah.
Yeah,
They have their cache in the background. I followed that path here.
right. Yeah. So I don't know if, caching those separately would help very much. It seems like there's already a subsystem for doing that. I don't think those are allocated fresh every time. I think those are recycled. So
Yeah, most likely. Yeah. Yeah, we'll see what we do about that in terms of our need for supporting the old kernel. We'll see.
right. Yeah, I guess you guys are mainly just interested in CentOS 8, right? So kind of the most recent version. So you're not really you're not trying to run on like something 5 versions old or something. It's just, basically the latest. So that definitely simplifies the overhead of trying to get that working and keep it working.
Yeah, the hope is that, but that's not short term, I guess. The hope is that they will kind of backport that feature. I guess there is a certain probability for that because they really backport much. But
right.
well, no guarantee.
Hey, maybe they'll even backport auxiliary device support. I mean, it seems like there's a number of NIC drivers that are using that, right? Like I think the Intel drivers are using that, and the Mellanox device drivers as well. So actually, that might be something else to look at, is to take a look at the Mellanox OFED for CentOS and see if they're packaging some sort of auxiliary bus module or something. Not sure. But yeah, it seems like there's definitely a few NICs that are using that, so maybe they will backport that. And if they backport it, then I guess we don't necessarily have to worry about it. We might just be able to use it.
Yeah, we'll have to see. Yeah.
All right. Oh, so just wondering, on the Stratix 10 devices that you're playing around with, have you gotten any of those designs to close timing yet? Or are you getting close? Or I mean, I know you're still working on it, but
yeah, we do have some designs closing timing, and we are reducing the number of interfaces to 2. So we're using 2 ports and 2 interfaces. 2 interfaces with 1 port each. Yes, that's the correct term. And that's closing timing.
Okay, but you need to do something with, I think, more ports, right?
Right. We aim at getting 4.
Gotcha.
And,
okay.
Yeah.
And when you turn on 4, then things are then you're having timing closure problems. Right. Okay.
Right.
I see.
Yeah. And most of this is most of this, no, but there are like some specific signals that pop up every time. So the recommendation is to run seed sweeps to get some understanding about which signals are actually those that are causing the issues and not symptoms for issues.
Right.
And yeah, so and some signals turn out always pop up in the top ranks, and that's those that we hunt down now. And yeah, as I said, this FIFO select thing
right. Okay.
pops up every time.
Interesting. Yeah, because I think you guys had had some changes that I need to kind of circle back and review again for that. I think I might implement that in maybe I'll take a look at implement that in a slightly different way. But yeah, so it looks like you've already made some changes to try to improve that situation, but it seems like those changes are not they don't fully solve the problem, right?
Well,
there's
they introduced or they resolved, like, I don't know, 3/4 of the problem.
I see. Okay.
So
so they helped a lot, but it's not fully solved
exactly
yet.
Yeah. So the
Well, I know
most
you were
important
talking
thing
about
is some
having
of these.
issues. Well, I know you're talking about having issues with the tools not consistently inferring the correct memory elements, right? So in some cases, it was putting in block RAMs instead of distributed RAMs, or what the M20Ks instead of MLabs. And you're sure that's not going on here, right?
Mm,
So when you're seeing these select lines popping up, it is using MLabs.
I think so, but maybe we should check again. So so yeah, I'll check back with my colleague. But I
Okay.
think he did look into the memory inference a lot, because that caused a lot of trouble.
Yeah.
But even before closing timing, so just fitting the design into the
I see,
device
yeah.
required these changes. Yeah, these changes are really mandatory to fit the design, and it helps a lot with timing as well. Yeah.
Right. Well, so the inference issues, mainly this was just about adding output pipeline registers, it seemed like, from what you're mentioning before. Is to make sure where the memory cells are directly driving registers instead of logic.
Right. So it's a little bit different than for Xilinx devices. So the Intel devices require, for proper timing, let's say, and also for proper inference, they require registers basically on all inputs.
On all
And
inputs.
it's not just data. So it's also write enable, address, whatever gets into this is connected to this RAM has to go through a register without further instances in between.
Okay.
So that's causing the complexity, I guess. So it's so obviously you look at data and say, okay, data is pipelined, but that's not all.
Right. Okay. Got it.
So yeah, write enables, byte enables, whatever. there must be a register, and it differs between MLabs and M20Ks, so they have different inference rules. And I guess that hit us. So M20Ks could be inferred, but MLabs couldn't.
I see. Okay.
And that's why we introduced these patches to make or to enable the compiler to actually infer MLabs instead of M20Ks. And that's why you didn't see this, because your device had enough M20Ks so it could be fitted.
Right. Well, I seem to remember pulling in the set of patches that you put together a while ago and not seeing any difference on the 520N MX board in terms of timing. So maybe,
yeah, possibly.
Maybe the maybe those particular changes didn't make much difference. Maybe the timing failures are coming somewhere else. So
yeah, there are more timing. So at least in our designs, there are in the end, some of the timing, so a lot of these timing issues went away, but then there is like common timing issues still there. Like the global routing is now exceeding capacity, so you have to split paths up to move them from global routing to local routing, and yeah, these regular timing issues now pop up. And so we try to move paths away from global to local routing, and that's why we introduced quite some pipelining on the Xilinx branches, because that's
right.
Yeah, it doesn't hurt, and it moves away a lot of signals from these paths.
I see. Okay.
And reset. So implementing resets differently and kind of manually allocated H trees helps a lot.
Okay. Interesting.
So
Yeah, I was running into some issues on the Xilinx devices with resets, and I ended up I ended up running, I think, the main reset through a buff G, and that seemed to help a lot on some devices. But I guess maybe you can't do the same thing on Intel devices.
Yeah,
So,
that's kind of the thing. I don't know. Back in my ages at university, they always also said, okay, use a buff G for reset, and then that's good. But yeah, I guess yeah, that somehow people moved away from this approach. I don't even know if this is actually applicable to Stratix 10 devices. Not sure, but definitely what helps is duplicating registers, constraining them to not being merged back again. So that's, I guess, one of the complexity of these flows nowadays is that synthesis does one thing, but the fitter doesn't know about it anymore and may revert changes the synthesis did. So then kind of synthesis duplicates registers, and because it thinks about, okay, a fan out, I have to put something in here, and then the fitter comes along and says, hey, that's a duplicated register, I remove it. And
or the other
well,
way around, you put in a
all
bunch of
the
registers
right,
manually, and then synthesis goes, oh, hey, these are all the same, merge.
right,
And then you've got
exactly,
one register that's trying to drive all over the chip.
exactly.
Yeah, that's one
And
thing I've noticed is
interestingly,
that it seems like the tools don't have a good way for detecting registers that are driving things in very different parts of the chip and saying, hey, maybe I should duplicate this.
yeah, and
That's
it's not so easy, right? Because it's not about the number of destinations
it's the
as you
locations where
you
they are. Yeah.
traditionally look into, right? It's like,
Yeah.
oh, it's a high fan out net. No, it doesn't matter if all these endpoints are within the same region. But the problem is if it's like 5 endpoints, but they are spread across the whole FPGA, timing will never
Doesn't
be
really
met.
work. Yeah.
Yeah, and
Yeah.
that's something. So there is, Intel is trying to provide some metrics to get some insight into this. So they are, I don't know the name anymore, but it's something like I think they call it spread or something. So it's like a 2D weighted timing impacts, let's say, right? Because then they try to measure in this the distribution of these endpoints.
Okay, so in this case, it's kind of trying to find a heuristic that allows them to figure out, how many endpoints are we driving over how much area, basically, right?
Yeah,
Instead of just number of endpoints.
right, and that's now it's not, they're not at a point that they use this for the algorithms, but they provide a view for you to get this insight into the design, so to get some feeling for which nets actually have the most impact into timing due to these effects. So it's not taken care or used in the algorithms yet, I guess. At some point they will use it. But for
Right.
now, they provide some analysis for the user to set thresholds and see, okay, and this is also different for every design. So you have to set a threshold, then you get a result of nets that are above this threshold. And then you can have, and then you can, I guess, highlight this in the chip planner so you can actually see, okay, it's really a small amount of endpoints, but they are spread across the whole chip, so it makes sense to look at this network. So I guess there is some tools for analysis, but it's not automated yet.
Well, that's a start.
Right.
Once they're looking
And
at the metric, then the next step is to, make the synthesis and or place and route aware of it. So,
yeah,
okay.
yeah, right now it helps to get a better understanding about the issues the tools have with the design you're working on. Yeah, so
Speaking
it
of
takes a
tools,
lot of
yeah.
time.
Speaking of tools doing weird things, when I was testing out all the designs on the various boards, I had one of the designs for the Alveo U280 fail timing. And I went and looked at the timing report, and the thing that was failing timing was a reset connection to one of the RAMs. And it was a really weird failure because it was from the register before it was sent to the buff G. So the tools had done some sort of, it looked like some sort of power optimization due to the net naming, where they had inserted another connection to the reset line, but like a previous like copy of it, like delayed by -1 cycles or something like that. It's like, oh, we have a copy of it from this register, I'll just use that. And then it ends up being way on the wrong side of the chip because of the buff G. And then we get this huge timing failure. I'm like, what the heck?
Great.
And the weird thing is that the particular block RAM that it was failing on was 1 out of like 3 or 4 in a FIFO. And only that one got this optimization. The other ones that are hooked up exactly the same way, because they were inferred exactly the same way, didn't get this optimization. So I'm like, what the heck is going on here? Very perplexing.
Yeah, then sometimes it's really strange what these tools actually do to the design.
Yeah. Yeah, and then figuring out which stage it occurred in, and is there a way I can turn this darn thing off?
Right.
Yeah. Yeah, there wasn't anything that I could tell in the logs about, you know, this particular change. Sometimes it'll print out like duplicating this register or whatever, but in this case there was nothing. So I don't know. Anyway, and actually they have a separate log or report you can generate for power optimization, and it showed up in there as a net that it had optimized, but it didn't say exactly what it did or why it did that. It didn't. The other thing that's annoying is you can't really get like a before and after kind of view, you know, because one thing that would be useful is, you know, when you're building a design in Vivado and it does like multiple rounds of place and route, it'd be useful to get a timing report like after the first round. It's like, where, I know you had a bunch of failures, where were those? Just out of curiosity. But you can't, you got to go through all the rounds and then you can look at the timing report at the end. So be useful to see. You know, if we work on these nets, then it'll make the process easier. Yeah, because at the end you get something that failed, but that maybe wasn't the nets that it was working on.
Exactly. Yeah. And these tools stop when they get the first path that fails, right? So at least the Intel tools, they don't optimize any path. If one path fails, they just stop. So you're not getting the 10 worst. You just get the 10 worst up to the point the first failed.
Right. Because it fixed the first 10. Yeah. And it's possible that if you fix those first 10 yourself, then, or, you know, made some modifications to make that a little better, then maybe that last one that it failed on would have actually worked.
Right, exactly. So and that's why the idea is to do these seed sweeps to get different results and see whether always the same signals end up being in the top 10. And then that it makes sense to actually work on them.
Right. Almost wondering if you do seed sweeps with some optimization passes disabled. Not sure.
That's possible.
Another thing I've heard people doing is they'll change the timing parameters. So they'll do the initial runs with a much tighter clock parameter, and then they'll loosen it up and see if it passes at the end. You make them work a little bit harder. You know, you try to close at 270 or 280, something like that, but only run it at 250.
Yeah, that's kind of the old way, over constraining, right? I guess that it wouldn't really work because still the tool stops on the first pass failing. So it doesn't try to do it harder.
Well, I mean, I guess it depends on exactly how the tool works. So I think Vivado, at least, it allows you to rerun various things if you do like a TCL scripted thing. So you could run the whole thing with tighter timing constraints and then loosen up the timing constraints and run everything again, or all the optimization passes a second time, and you know, see if that makes a difference. I don't know, because it's possible it's going to optimize stuff differently if you give it a tighter timing constraint. I don't know. Anyway,
the problem is changing one tiny bit. Always you'll get a new seed. So you cannot
Yeah.
do a seed sweep if you change a constraint. It's a new run.
Okay. Yeah. That's well, I guess maybe that's a characteristic of how the Intel tools work. I'm not sure if Xilinx is exactly the same way in that regard, but anyway.
Not sure. Yeah, that's possibly specific. Yeah.
Anyway, I'll take a look at this this pull request for the link status modifications, and maybe even get that merged in today if it looks good. And I don't know if there's anything else that we want to discuss, or anything else that needs to be discussed. Anyone have any other questions, comments, anything?
Just a quick one, because you mentioned the MSI strangeness in this world.
Mhm.
We also have such a machine which for a long time just worked with one vector, and we didn't know why on Earth it wouldn't switch to 32. And with this machine, the solution was to switch on all needed BIOS items for IO MMU operation. It seems to be related to IO MMU. And I recently, last week, made the discovery that, I mean, this is all off topic kind of, but if you want to have an IO MMU emulated within a QEMU virtual machine, you can do that. And I also there saw the same effect. If you don't have the IO MMU emulation enabled, you get only one MSI vector. And you have, if you have the IO MMU emulation within the VM enabled, kind of nested, then within the VM you get all the MSI vectors. There are 32 in the case of MQNIC. So it's at least that's one data point. I don't know why, I don't understand it, but that's how it is.
I mean, it seems to me that if you turn off the IOMMU, just turn everything on. I mean, it almost seems like the IOMMU would be the thing that's limiting to a smaller number of vectors. So if you turn on the IOMMU, then it would give you fewer vectors under certain
it's really strange,
so.
Because I really also was surprised why QEMU, obviously the emulated hardware kind of has the same behavior. So I guess it's not a kind of a special behavior of our machine or your machine, but it seems like it's a kind of a basic fact how things are done.
Yeah, I mean, it's definitely machine dependent. I'm not sure if it's BIOS dependent or dependent on the chipset or something else, because, well, it's okay. So here's the deal. This workstation machine that I have here, it's a Dell 7920 with a dual Intel Xeon 6130 CPUs. So Xeon scalable devices. I'm not sure what the PCH is in here. This one is only giving us one MSI per device. In the CSE building, we have Dell, I want to say R540 servers, dual Intel Xeon 6138. So very, very similar CPUs, also Xeon scalable. I mean, it's like a different binning or something, slightly different number of cores, slightly different speed, but extremely similar chips. And that gives you all 32. So yeah, it's like same era of machine, same series of CPU, and we're seeing totally different behavior. So, and the same manufacturer, right? They're both Dell. But one of them's a server, one of them's a workstation. So yeah. Very perplexing. So yeah, that's a good point. I will take a look at the BIOS settings on this thing in terms of the IOMMU. This thing doesn't give you all that many buttons to push, but I'll take a look.
Yeah, the problem is with all these settings, they are kind of not standardized. Every vendor names it differently. Also the VM options there are.
Well, the more annoying thing is they don't always expose all the settings, right? I mean,
on top of
some
that,
of them will give you a very, very condensed list. So that could be the difference right there, is maybe I think that the servers have a totally different BIOS interface that maybe gives you a lot more options than the workstation machine. So I don't know. I'll take a look at it. Yeah. But yeah, IOMMU involvement could certainly explain it, because I know that's a major difference between MSI and MSIX. With MSI, you only have one register to store the address. With MSIX, every vector has its own address. So I can definitely see where with MSI, you know, if you need to put each vector on a different page or something, well, you can't do that with MSI, but you can do it with MSIX. So, you know, that would make
Okay.
sense
Mhm.
as for having some involvement with the IOMMU. But it seems like there should be some way to get all 32. But at least maybe that's some Google search terms. We can't be the only ones who've run into this problem.
Yeah, I mean, I came across this problem, I don't know, 5, 6, 7 years ago, back then working with SATA devices, the AHCI standard. And from back then, I kind of remember that at least for some time, Linux didn't even support MSI in a way that multiple vectors would be assigned, even if it would be possible. That's what I
Oh,
remember
interesting.
from back then. And that's why I was kind of surprised last year when we started with MQNEC that, well, that you are using MSI with MQNEC. And I thought, well, I thought Linux didn't support that, or no, it's
Interesting.
not the common case.
So the only reason I went with MSI originally is just it's a lot easier to implement, right? You don't need
Yeah,
much
yeah,
in
sure.
Verilog to make it work. And it worked on all the machines I was using at the time. So, and because it started life as a research project, you know, if it works, that's good enough.
Yeah.
But now we're running into some issues with it. So, okay, you know, there's reasons to move to MSIX. I mean, MSI is limited to 32. MSIX, we can get a lot more. And if you're running on a machine with lots of cores, having more interrupts is probably a good idea. So, yeah.
And one more data point, also kind of unrelated, just very strange. I have to check that again. The point is, within our system, we had the idea to have multiple distributions running on the same system, but doing it within VMs with modern KVM, not much performance degradation and so on. We were doing that. We are doing that, and we're doing that in the past with other projects, and had good results so far. Just running a VM, passing through the PCI device, and we also do that within our current project. And when enabling the IOMMU within the VM, and then I saw that all of a sudden all those MSI vectors are there also in the VM, but all of a sudden the MQNIC doesn't seem to work anymore in a strange way. The following way: packets are received. It makes sense if I send 5 packets, there are 5 events. It kind of makes sense, but the contents of the packets is all 0. There's no data, all 0. It's like the DMA engine of the MQNIC is not able to write anymore into the pages, but anything else is working. Kind of the handshaking between the MQNIC, the queues and the driver and so on. Just the pages are empty, zeroed out.
Can you send? Does it send data?
Did I try that? The experiment I wanted to do was about receiving, so I didn't send yet. I have to check that again. It's very strange. I guess there's a bug in this IOMMU implementation, which I enabled inside the VM.
Well, I don't know. It's possible there could be a bug in Corundum too. I've never tried using it under a VM like that. I don't know if anything changes on the PCIe side when you try to do that. Definitely worth looking into, getting to the bottom of that. So the other thing it's going to be writing out is completions and events. So you can go into the driver and just have it dump out the, just do a hex dump of the completions and make sure those are not all 0. I think something would It's like if the completions are being written out, then it seems like it should work, right? Because the completions would contain like the packet length, right?
Yeah, right.
So if the completions are being written out as all zeros, then you wouldn't be able to receive anything because all the packet lengths would be zero. So
right. I have to look at that again. It was a quick try. I saw, well, everything is zero. Okay, I need to
something weird is
get
going
done
on here,
anything
yeah.
else. And
Interesting.
I
'cause
resorted to right.
Yeah, because I was thinking, if we're potentially going to provide, remote access for people to hammer on stuff, being able to run stuff in a VM would be cool because I can just say, here, use this VM. You can hammer on it as long as you like, and it's nice and self-contained,
Right.
But
That's
I've
also
never
was our
tried using
idea.
the cards with the VM, so I don't know how well that would work. So anyway, something to think about. If we can get to the bottom of it, that could be useful. So. Yeah, this might be something worth discussing at some point on Slack, is what your setup looks like there, and I'll see if I can replicate it here and see if I can repeat that problem, and we'll figure out what's going on. If this is a QEMU problem or a hardware problem or something else. Who knows? But yeah, that's a good point about MSI. I'll take a look at the BIOS settings on here and see if I missed something. I don't think I looked at that very closely. Although I don't think I turned off the MMU, so I don't know. I'll take another look. All right.
Yeah, sometimes it's strange. I also have the impression that sometimes these BIOSes forget some things. I mean, with our workstations, there's a setting where I really don't understand why you would want that. There's a setting that the machine halts if a PCIe link goes down. It really halts. The system crashes. You need to reboot. I don't know why you would want that. So there's a setting where you can disable this behavior so that, well, there's just a dump going on inside Linux and you can probably shut down or do whatever. And this setting is kind of reset by the BIOS every now and then. I don't know. It's strange sometimes.
Well, they probably just have some bugs, right? BIOS.
Yeah, most likely.
Such a pain. Have you tried updating the firmware on there? I know Linux has their firmware update framework. I don't know if you've looked at that at all. It's pretty easy to install that and just see if it detects any updates. It seems to work pretty reliably on like Dell machines and whatnot for detecting and downloading the system updates and whatnot. On other machines, it doesn't. I guess they don't. The manufacturer doesn't support updating through that framework. But always worth taking a look at.
Okay.
No, that can save a few headaches.
Yeah. Okay.
Yeah, because I ran that on my workstation machine when I first got it. It didn't want to sleep properly. Once you get the updates on there, new BIOS version, it's got to update like 50 different frapping firmwares on there. Afterwards, now it goes to sleep properly. So go figure. All right. Anything else to discuss, or shall we reconvene in 2 weeks? Okay, I guess, well, it's been a good discussion today. Half hour overtime, not going to argue with that. I guess I'll see all you guys in 2 weeks.
See you in 2 weeks.
See ya.
Okay, thanks.